Okay, this is part 2 of Notes 5.2, Relations and Functions, with some talk about domain and range. Now we're going to get into the bits of what a function is. We just got done discussing what a function was like a vending machine, and if we had an input, we got an output. But now we're going to talk a little bit about the workings of a function, some of the definitions that we need to further discuss it. So let's pull these definitions up. So the first thing we need to discuss when talking about a function is what a relation is. Okay, not like you and your girlfriend or your boyfriend that happens to be a relation then is something like that. There's a sequence of events or some kind of connection between two things. And we'd like to say a relation then is a set of ordered pairs. Okay, ordered pairs, also you can talk about them as coordinate points. Would look like any point that you'd have, but it would be more than one. So there's one point, it could be another point. Again, whatever the set of points or values that come in and out of the function, that was what we're talking about here, the relation. So if I put in a certain number, I know I'm getting one out, and I can repeat that process for however many relation or coordinate points that I have. Okay? An ordered pair or coordinate point is represented by an x coordinate and a y coordinate. And I've kind of spoiled that up top there. Okay. Again, x value, y value. And there can be more than one in a relation, so x value, y value. So each one is an x and a y value. An input, your x value, an output, your y value. Okay. So let's go ahead and get the official definition of a function. So a function is a relation that assigns exactly one variable in a range. Okay, range is our y coordinate, so this is kind of like our output. Not kind of, it is our output. Okay, so it assigns one output to each value in the domain. Okay, or our x coordinate. All right, so a function then is a very specific vending machine. For every output, there's exactly one domain. That means that if you press a value, that there's exactly one, if you press a value on the vending machine, there's exactly one snack that comes out of it. So let's talk about this domain then. Domain is the set of first coordinates, or x coordinates, okay, also known as x values. The line moved on me. Okay. So the range then is a set of second coordinates, also known as y values. Okay, so what we've got here is some type of an operation, some set of numbers, again, a relation, right, ordered pairs, where there's an x coordinate, again, our input value, and the output value that comes out of the function, the y value, the second coordinate, and that makes a function. So the way that that works is you put in values, you get them out. Now we can test to see if these are functions or not, okay? Because not every relation is a function. And one of the tests that we have to do this is called the vertical line test. And the vertical line test is great because it's a visual test. We can also do that by checking the domains and seeing if they go to the outputs, the ranges. But let's talk about this vertical line test first. We like to write it shorthand as VLT, not BLT, that makes me hungry. But here's the test. So it's a test used to verify if a relation is a function. Okay. If any vertical lines pass through more than one domain of the graph, then the relation is not a function. So it's a visual test, and I'll show you what that looks like in just a minute. But we do have a test to see if our relations, points that we're plotting, is a function or not. Okay, and there's one other thing that we need to talk about when we talk about domain and range so we don't get confused, because on the first couple examples I'm going to use, they're going to be discrete functions. A discrete function or discrete domain then is a set of points that can be non-continuous. It's a better way to describe it. They don't have to connect. If I were to graph them, they could be individual points like this. I wouldn't draw a line through them. They'd be separate, maybe whole numbers, decimals, whatever it happens to be, but it doesn't mean all of the points in between, so I would not draw a line through this one. That would make it a discrete function. Sometimes it looks like a set of table values, depending on what it happens to be, assuming that it's just the values in the table. So it may be like 1, 2, 3, 4, they're separate. Okay, maybe you get them in set notation. We'll talk about that in a second. So maybe it's a set of values. Here's your domain: 1, 2, 3, 4. Again, these are just the inputs, right? Because I said domain. They may be just separate points. So if it's a discrete, it's going to be just values that come out, just individual values. And we've got a way to talk about that. So that's what a discrete function is. A continuous function then would be where we'd have all the points we were just talking about, but in this case it would be every value in between. So a continuous function is going to have every value. And over here, when we talk about domains, notice I listed 1, 2, 3, 4. I could list the points because they were individual and not all the points in between mattered. But in a continuous function, we can't list them because if I put it in set notation, we'd have to have 1, and then we'd have to have 1.01, and then 1.02, and then 0.1.03, and then every other, I'm skipping tons of decimals in there, but I'm skipping all the decimals. We couldn't list all of them. It would take too long. So we can use a set notation to kind of talk about the domains and ranges of a discrete function if it's separate points. And if it's a continuous function, it's every point in between. We generally need a different way to talk about that. And what that's going to come up to be is we need to use inequality notation. So we're going to talk about a range of values. So our domains then is all the values between some low end value, whatever that happens to be over here, and between this value, including all the decimals and all the points that we could come up with. So it's everyone. So there's a little bit of difference in the way that we talk about domains and ranges based on the fact if it's discrete or continuous. All right, let's jump down here and grab another note. Okay, so So what I was describing up here, the way I'm talking about this domain, and I'm talking about this domain over here, I'm talking about what we refer to as interval notation. So let's write that in. So interval notation, kind of like it sounds, an interval, a space or some section of something, is a way to define whatever the domain is, a set of numbers, all the numbers. It's a way to go ahead and describe a span, again, of an axis, commonly x and y, that we talk about, usually referred to domain and range, but we'll use it in other places as well. So this gives us a way to talk about it. So in an inequality interval, we use that, and I was talking about it over here. So that's what I was discussing here. And in an equality, we say, here's our domain. It's this value x. It's all these values x, whatever we want to plug in there, right? Because it's a variable. And we say that it's greater than or less than some values on either side. So we use inequality notation to describe ones that are continuous. Okay, I should probably reverse these next time. Whatever that whole range is. And so then the other notation then, or the interval notation, we just refer to it as interval notation. It kind of defines, maybe set notation would be another way to say it, set notation. But that's for our discrete. And again, that's individual values. So I really want to draw attention to that because I've seen some kids make some mistakes there. They tend to think that they like the set notation. It looks easy. They can see the values. They can write them. But that's not the only way to write it. It really depends on what type of function that we have. Is it discrete or continuous?